I'm going to work through this problem in real time, explaining my reasoning like I would in an interview, including mistakes and course corrections. If I hit a wall after a solid attempt, I might check a solution, then break it down and code it myself. Given an integer array nums and an integer k, return the k most frequent elements. You may return k most. So it's basically telling you what are the top 2 elements. So this basically tells you the the answer size or the output size. So it gives you the top 2 values in order of frequency. You should give us. So for this case, it's in any order, so it doesn't matter. So this could be 2, 1 if it wants to. So since the value 1 appears 3 times, that's the most that this nums array has, that's going to be in the answer, and 2 is the second most, which has a frequency of 2, and goes in. Okay, good. My question was going to be is if there's going to be a unique answer. So pretend there's be 2 3s. There could be multiple answers for this since there's a tiebreaker for the number 2 spot. So I'm glad that it got cleared up with constraints. That would have been my question in an interview. Something I was told is like, what's the type of constraints given? So like, that's something good to ask in an interview. I typically don't. Maybe I should start doing that and feel comfortable doing that. But yeah, so we know that k would be at most the number of unique elements. So that's good. And this comes in many different orders. I see. Okay, so I think I have a grasp of the question, what it's asking, and I gave a decent explanation of the question. Constraints can be important. Okay, so I'll ask about what's the input size. That's one way of asking the question. What's the expected input size? And they say about 10,000. Wait, no, that's not 10,000. Wait, 10. 100,000, 10,000, 100,000. This is 100,000. So we know that this has to be at least n log n type of solution, given that type of constraint. So we should ask that. The thing is, I'm trying to figure out. What would be the solution for this? If a hash map would be the best case scenario. Okay, so let's think of possible solutions, because I actually don't know the solution on top of my head right now. So if we did do a hash map, so like let's say this is solution 1, hash map, right? So we'll go value, frequency. And we could always add up the frequencies, right? So for the first example, it'd be 1, 3, it'd be 2, 2, and 3, 1, right? The thing that I'm trying to figure out, so because if I iterate through this hash map, so the hash map, the way that I would get these values is via for loop. Through nums. That's how I would get these values. If I iterate through this hash map, I'm trying to figure out how do I get the top k value. A vector of pairs, where the vector where the first value is frequency and the second value would be the value. This. Oh wait, my algorithm time complexity must be better than n log n. That's crazy. That's a follow-up question. Let's see if we can do it. The reason why we could do this way, so let's pretend we iterate through the for loop to get basically the same values right here. The only thing that would be different would be the frequency would be 3 to 1, 3 1, 2 2, and then 1, 3, right? Let's say we need to sort it out, right? We need to sort it by the end. We just take the first k elements. We sort and then take the first k elements. If I can spell sort correctly. This will give us TC. I don't know why I read that. This would be a TC of n log n, because we had to sort it out via the pairs, right? Because we sort via the frequencies. Space complexity would still be O of n. I think of better solutions, but we need no, that won't work out either. Okay, so I posed a question earlier. How do I get the top k frequency by iterating through this hash map? So we iterate through the hash map. We're gonna create a vector. That'll be really complicated. So what I was thinking is like try to populate the top k frequency, putting it into that vector of size k, and then we iterate, and then we go through the hash map again. But then this becomes really slow. I can think of the solution this way, but I feel like I'm missing something if I try to go this route. I feel like there's a way to do it. I just can't think of it. I mean, if we iterate through this hash map, we could just put it into like a frequency vector. Sort the vector, the frequency vector. It all goes back to sorting, and then take the first k element hash map. I'll just sort in reverse. Right, yeah, you have to do reverse. It all ends up being like that. So I think I'm gonna go with, so this is when I would ask for a hint to get to me if it needs to be better than n log n. There must be some key detail that I'm forgetting. Because the best solution I can think of right now is this solution. So I'm gonna go with implementing this solution, because I think this is much simpler than the first solution, and I think it will order by the first value first, and then go on after that. So I'm gonna implement this first one because I can't think of a faster one. It's called bucket sort. Did I learn bucket sort? Okay, I'll look up bucket sort after this. I'm gonna implement this first, and I know it's not the optimal solution, unfortunately. But even if it's not the optimal solution, you can still show your thought process on things and your coding skills by implementing it, even though it's not the most optimal solution. So sorry guys, I wasn't able to find the optimal solution here. So we're gonna be, it's called, it's equal to, usually you wouldn't write this in a function, but I'm gonna do it in this case. And this just simplifies this right here, so it doesn't look too long or intimidating. And I'll call it frequency vec. I kind of just like did hand wave right here by finding the frequency. Hilarious. I did a hand wave of like, this is the values we're gonna get, and I didn't notice that. That's deduction of some negative points. Okay, so with that in mind, we're still gonna need this frequency vector. It's just how we get it is gonna be very obtuse using the hash map. Quite unfortunate, we're kind of reversing the key value pair, so we won't be using that for now. Not vector. So if I was the interviewer, I would be giving me a no hire or a lean no hire, because I couldn't find the optimal solution, and then I didn't see the errors in my ways when trying to plan it out, right? It's very important to figure out all like the key details when thinking of a solution before implementing it. Unfortunately for me, I didn't do it nicely enough. But I do think there's some pretty nice qualities that I've shown so far, even though it's not my best work. So we're gonna do num plus, which again, it would be this value frequency. And then we're gonna iterate through this val of frequency map. Yeah, and then the frequency vec push back will be of, I think we can do this, val key, and then we simply sort it, and it should automatically use the first index for the sorting. I'm gonna actually look this up. How to reverse sort in C++. I think I used the R begin and R end. Oh, interesting. You use the comparator. Ah, because you use less. It's not lesser. I always got confused by less. Why is less and then instead of lesser? Because there's a comparator called less, I believe. Okay, so that would be in descending order. Gotcha. This one I'll put a note in. I think also I would have to, because it's a function. It is a function. So we have it in reverse order. So now we're gonna have answer vector int, and then for int I is equal to 0, I is less than k plus I. We shall do answer dot push back c map of frequency vec I, and since it's a pair, we're gonna use second. It's just second like that, and then we return answer. I'm still gonna go through a dry run, even though I know I took overtime. So for a dry run, we're gonna use this simple one right here. Okay, so what do I need to? So we have frequency map here. This one's pretty simple, right? We can kind of see once we like iterate through all this. I shouldn't do the hand wavy thing, but once we're here, we have 1, the value 1 will get you 1 frequency, and then when we get to here, is we can do this frequency map num++. It does it again, so 2, and we keep iterating through it until we get to 3, and then we have 2, which would be 2, 1, and then once we get to the second 2, we get the 2, 2, and then 3. And then for frequency vector, once we are iterating through all of it, we might have a different order of things, because I don't know how the order we iterate through the hash map is going to be like, since it's an unrolled map. It should be like 1, 3. And just keep in mind that the pair would be frequency and then value, and then we sort it, the frequency vec, and it'll be of the first value, which is the frequency. So it should end up something like this. Okay, never mind. I lied to you. Let me undo that. Which would then be 3, 1. I'm just gonna write this manually since I'm messing up with the everything else. And then 1, 3. Oh, so I realized going through this dry run, I messed up when pushing back. We don't need to go in the frequency map. I don't know why I thought I needed to go back to the frequency map. I have everything that I need in frequency vector, which is just that. So then we start putting in to answer, which would be 1. We push back 1 into it, and then we push back 2, because these are the first 2 elements, since we sorted it in descending order. Any other syntactical mistakes? Yeah, guys, so I don't think this is the optimal solution. I think there is a faster solution. I just can't think of it right now. So I apologize for that. But let's see if this at least passes the test. No, it doesn't. Oh, it's because I didn't see this error right here. It should be frequency vec. .c. Another syntactical mistake. Delete that as well. Okay, so this at least passes the test. Wait, let me quit this. Let me write it. Yeah, so it's not the fastest solution. So let's take this as a learning moment and figure out when I say figure out, look at the solution. Use a heap. I totally forgot about heaps, min and max heaps. So we got this. Oh man, he kind of complicated this. There's no reason to do it this way. You can, oh wait, is there actual reason? He could have just, to make it simpler here, I believe we won't have to create this special, I'm blanking out on it's not a function, but it is a function. I'm forgetting on my vocabulary. Numkey, what's this called? Lambdas. They're lambdas, bro. Oh my god, bro, why? I can't believe, yeah. You don't have to you don't have to create this lambda. Blanking, bro. Blanking. This is not my best performance. Yeah, so I think if you just reverse the order, so if you do entry second right here and then entry first as the second place, we should be okay. Is that the fastest solution? Oh, so we found a better solution here. Hold up. What's the solution? I'm pretty sure I've submitted something like this before, but I just couldn't think of it this time, which is unfortunate. Why this? Num size +1, okay. So for the, okay, so frequency, the frequency value, okay, I see why this is happening. And then you go in reverse order. I see, so, okay, so the basic summary of the solution is we do the same frequency map that we have here. And then we have a 2D vector. We have vector or vector. The reason why we have this is because there might be multiple values with the same frequency. So let's say we have 1 and 2 that show up 3 times each, and they're the top. For the index, for the third index, okay, this frequency value, I guess technically, for the third index, assuming 0th index, we push in the 1 and the 2 into this table. Then we go in reverse order. Then we iterate reverse. So we start at the end and then go to the beginning. And then we start iterating through each vector within it. And most of them are going to be empty. If it's empty, then we just pass through it, right? But we go from the end to the beginning because that is what shows up as the most frequent values. You use the ones that show up once or twice near the end, or near the you push that into the answer at the end. So we're gonna implement that. Yeah, let's implement that. I know I just saw the solution, but we should still use it as practice. Given the practice, I will even go through the possible solution for it, right? Top solution, the way I would explain it to the interviewer is we will have a hash map, which will keep the frequency of each value. And then we will sort the frequency value through some bins via a 2D vector. So we will just say frequency to 2D vector. We iterate through the hash map and fill up this frequency vector with the value in the index is described by the frequency. So if a value shows up 3 times, it will be in the index 3. Then we will iterate backward from the end to be through the frequency vector and push into a 1D called answer. And we do that because we want the values with the most frequency. Yeah, that's the solution. And the reason why it's a top solution is because the time complexity is O of n, because we are, for each for loop, iterating through the same values over and over again. And the space complexity is, again, we keep the maximum value of whatever the size of nums is. Okay, so let's delete all that. And let's start creating a solution. We'll call this frequency map. And then we'll do a little for int. We don't have to have the indices, so there's no need. Yeah, and my apology guys for not seeing the solution straight up, but this is me working through it. So in frequency map, ++, and that gives you the frequency. And let's create our 2D vector, and it'll be called frequency vector. And we'll make it size, we'll make it of size nums.size +1. And the reason why is because they could all be, in this instance, ones. Let's say 1, 2, 3, 4, 5, 6. And we want to place the frequency in index 6 for this frequency vector. Right? If it's only, if we say that the frequency vector is the exact same size, there will be no indexes 6. It will be at maximum index 5. So that's the reasoning for that. So for key val. Or I guess I could say just frequency within frequency map. We'll do vector vector of index frequency pushback number. And we can do this because we already established the vector size. So we already allocated the memory needed in the indices. They're just empty right now. Or they're just established as empty vector. Okay, so we put the numbers in their frequency bin. So now we shall do this. So int I will equal to frequency vec.size -1, and I is greater than or equal to 0. I guess there's no reason to we wouldn't put any zeros in. So there's actually no point. Yeah. I also forgot to establish the 1D vector answer. So we didn't do. Since it's a 2D vector, we have to do one more, which should be pretty simple. We don't have to special here. We go through all the numbers in that frequency vector. This is a 2D vector, but within that frequency 1D vector. And then we do a simple answer.pushback of if answer dot size is equal to k, return answer. And then we need a return statement always, because it doesn't think of it, just return answer here. And this should give us the same solution, unless I messed up somewhere in terms of syntax. I'm not gonna go through the examples again, dry run it, but it's a nice, it should be a faster solution now. This is slower than what I wrote earlier. This is so much slower than what I wrote earlier. Maybe it was just a bad submission. Okay. Cool. The runtime that it was me, it wasn't this. It was like a lot slower than what I wrote earlier, which was weird, very weird. But I think it was just LeetCode being LeetCode. So yeah. So we have the vector size. The space complexity is still O of n, since the maximum of B would be the number of elements right here, num length. Similar to this one, just add one more, which still be O of n size, and same with frequency map. And then all these are similar case. Even though this is a 2D vector, the amount of values in there would be O of n, being the num size. So this is still a O of n time complexity. So yeah, that is the end of that question. I know it wasn't the cleanest. I would give myself a no hire on that one, but that's how I honestly answered the question. So hopefully once I visit this question months from now or a year from now, I remember it, and even if I don't, I can easily find the solution again. Hopefully that's the case. Anyway, I hope everyone has a lovely day. Peace out, Girl Scouts.